have a session from Yokogawa. So we have our expert, Mr. Ashok Kumar. He is the product manager in the test and measurement instruments at Yokogawa. And I think there is no need for a big introduction about Yokogawa. And anyway, sir is also having the profile he'll be just discussing. It is a very leading company of all the instruments, and mainly for power electronics, they have a very good solution. And at our end, we have the MSO with us. We have got their MSO. It's a very perfect instrument for power electronics application, as well as they have the power quality analyzer. That is also their power quality analyzer. Even in many of the industries, they are using it. And I think he'll be a best person to tell you people like what type of isolation is required when you want measurement, because whenever you deal with power electronics, it is little different from the other instruments what you're using. Maybe a DSO or a CRO you are using it, but when it is for power electronics application, many isolation is required, and frequency is also involved. Like it is not only for say 20 megahertz or something, you go for 250 megahertz or higher megahertz. So what type of instruments, like for a particular application, how to choose an instrument, or what are the solutions they can give, and how to overcome the other. Like he will just discuss all the issues which are there when you're connecting a power electronic device or a renewable energy system to the thing, and how to use their instruments and measure these things perfectly with accuracy. Okay, so that is the main aim of this session what we have planned. And we have here, sir, we have experts. They are like, sorry, participants from different colleges throughout India, and all of them are mainly, that is the beauty here. They have all from power electronic background, and they are working in this field. So I think they are the best participants here. Yeah. And we have different centers, 6 centers connected with us. And there also, if you see, all of them are mostly research people and faculties who are working in this area of power electronics and renewable energy. So I think our participants are also best group of participants who are keenly waiting for all these things. And I hand over the session to Mr. Ashok Kumar.
Thank you very much, madam. Good morning to all. Just before starting this, I would like to give a brief introduction about what is Yokogawa, what kind of instruments Yokogawa manufactures, what are the solutions we can offer in terms of power electronics and in terms of the renewable energy, what kind of application we have. So for that application, what kind of solution in terms of test and measuring instruments, and those solutions can be achieved as per the latest IEC standards or Indian standards. So what is the industry trend currently which is going on? So what kind of future technological requirement, what market demands? So I'll just take you through the brief profile of Yokogawa in corporate profile. So Yokogawa, if you can, so the symbol which shows, it's a, if you see the top angle of the our logo, it shows the cutting edge technology which we develop in our product line. And if you see the bottom curvature of the equipments like this and this, so it is a warm-hearted people of the Yokogawa's company's nature. And the color, yellow color, represents the shining or the brightness which equivalent to the sun. So that shows the we are always taking care of the future technology in terms of needs. And as a company, our goal is to contribute to the society through a broad ranging activities in the area of measurement, control, and information technology. As a individually, we aim to combine good citizenship with a courage to innovation. So Yokogawa Electric Corporation is incorporated in 1915. So this year it's 102 years old company in Japan, and it started with Mr. Dr. Tomosuke Yokogawa in 1915. So he founded Yokogawa in the year 1915, and we are the first. Yokogawa is the first to place an electronic meters in Japan. So we started Yokogawa in terms of electric meters 102 years back, and this shows our journey of Yokogawa till 2015. So in 2010, Yokogawa Measuring and Instrument Business as formed a separate company called Yokogawa Meters and Instruments Corporation, which caters only for the testing measuring instruments. So our main businesses in terms of like in, industrial automation and solution services, measurement business, aerospace products, and Yokogawa corporate in America, Europe, and we have a Middle East engineering and China. And these are all the supporting documents, and it is headed by board of directors and chairman. And the worldwide employs around 20,000 people, and within Japan around 9,000, and outside Japan around 11,000. And we have a headquartered and branch offices in 10, group companies and 14, and total 187 representatives in Japan. And this some of our global this thing like Yokogawa Europe, Yokogawa China, and Yokogawa Japan. It is our headquartered, and Yokogawa America, Yokogawa Singapore, and Yokogawa Middle East. Okay, and we have 13 subsidiary companies and 71 affiliates outside Japan. And this is our manufacturing facilities. We have 5 manufacturing facilities within Japan, and around more than 18 manufacturing facilities outside Japan across the globe. Includes India, Singapore, China, and Brazil, Netherlands, Germany, Korea, and US. And our service organization, it's spread across all over the globe, and we have a global response center where any escalation or any service calls will be logged to the across the globe, and it will be centralized in, and immediately it works by 24/7, and it supports the customer immediately. And this is some of our these things. These are all the board view of some of our product line. Like you might be seeing this SCADA and distributed control systems. So Yokogawa is one of the leader in terms of SCADA and distributed control systems, and PLCs, and some of the flow meters that is in the process industries. And these are all the some of the analytical instruments and recorders, analyzers, and controllers. And coming to test and measuring instruments, these are all the like scope recorder, optical spectrum analyzer, high precision, world best accuracy, and OTDR, and some of the life science products and aviation products. And its approach towards the R&D segment. And quality, yeah, quality is the first and uppermost priority in Yokogawa. And we talk about quality assurance, quality improvement, and quality in mind. And Yokogawa approach to corporate citizens, like what the society who takes care of like a contribution towards the society as a organization, and environmental management. And this is a brief introduction about the uh, company. So I'll be discussing about the measurement, like what is power electronic systems. Basic I would like to describe here through the basics, and in that basic applications where the instruments can be utilized to test and to identify the, either it could be a losses, either it could be a frequency variations or power fluctuations, and whatever it may be, which is in terms of occurs in terms of the in the power electronics. So the contents will be power electronic systems, modern electrical drive systems, power electronic converters and electrical drives, modeling and controlling the electrical drives. So what is power electronics? You might have known all these things, but as a basic this thing, like the field of electrical engineering that deals with the application of power semiconductor devices and control and conversion of electric power. So this like input will, you will have a either DC source or AC source or unregulated sources, which will be fed into power electronic converters, and output will be a load, either it would be a inductive load or capacitive load or resistive load. And of course the feedback will be taken through some of the sensors, and it will be controlled. Again, feedback has been given to the power electronic converter with respect to reference, so that the desired output or the desired result will be achieved using the control loop or feedback system. So you are free to ask any questions at any point of time, or if you feel that okay at the end of the session also. So we'll be theory part will be a some extent, and we'll be focusing more on the practical also. So why power electronics? See, power electronics, yes, now each and now daily our day-to-day activities, one or the other way it is linked to the power. So from the starting from our mobile phone till the industrial, so without power we cannot do, or we cannot achieve our day, or we cannot do any our day-to-day activities. So to charge our mobiles, or nowadays the technology is changing towards the automotive, like it is coming a solar or hybrid vehicles. So to all this, at least one or the other way we are linked with power. So without power we cannot move ahead. So that is the status where we have moved till today. So input source again same like AC DC, either it could be, but ultimately what kind of output are ideally where we are moving. So that is where so if you see the power electronics industry in the year of 1990 1900, so the mercury arc rectifiers or vacuum tube rectifiers were there. Or if you in 1957, then the thyristor has been invented. And in the mid of 1970s, power diodes are, and the application of fast switching. So switching is a most critical parameter in today's this thing, how fast we can switch the device. So while doing that switching, how we can minimize the losses. So that is the today's challenge. So each and every companies are working, who are in the power electronic segment, who are working on how fast we can switch at the minimal loss, how maximum efficiency can be achieved. So if you're talking about like thyristor, like microprocessor, MOSFET, or IGBT, or SCR, and all those things. So these are all the power electronics history is precisely follows the matches the breakthrough and evaluation of power electronic devices. So why power electronics? Like other improvement of power semiconductors fabrication. So the technologies, yes, one side we are talking about how to reduce the losses and how to increase the or maximize the efficiency, and at the same to do achieve that, what kind of challenges which we are facing in terms of fabrication of semiconductors. And decline, the cost is also declining every day. So the semiconductor manufacturing, one side, yes, the other side, it is coming to a miniature as small packages with a high power handling capacity. So and the advantages of semiconductor fabrication, like earlier we are using ASIC, now FPGA and DSPs. So these are the technologies which is developing, and at the same time the complex algorithm or the software or firmware which is getting more and more complex. Some application of power electronics typically used in the system, like domestic and commercial applications, like our household, starting from mobile to the fridge, refrigerator, or TV, or mixer, grinder. And nowadays, like even toys, smart homes are coming up. So with a remote control we can control the complete appliances sitting somewhere in the world or in the city. So that is the kind of smart technology which is we are adopting today. And industrial applications, now we are talking about in terms of either transformers or motors or pumps. As per the Bureau of Indian Standard, we are talking about star rating. So the star rating which goes higher, the power consumption or the efficiency is better. Power consumption will be lower and efficiency will be better. So you might be seen in the many of the TV advertisements which gives the BIS. So use more and more star rating products, like starting from our CFL or LED bulbs to the motors or pumps or refrigerator. So nowadays when we go to a shop, like buying some either TV or refrigerator, first we think we'll see that okay, how much star rating this product has. So the more star rating which you have, so the lesser consumption of the power. So now the government is also thinking, not only government, the global initiative is, rather than generating, how much power we can save. So saving, it's almost one watt saving is equivalent to 10 watt generation. That is the kind of awareness which we are spreading today. And we need to concentrate more on how to save the power. Okay, and adding to that, so other global countries, like global other countries are way ahead of in terms of saving, whereas India still we are in a very nation stage. It's like I would like to give one example, like other Europe countries. Normally we have a habit of switching off the TV in the remote and sleeping or whatever it is, so we don't bother to switch off the TV by physically by switching off the switch. But we don't know at this in Indian situation what could be the power consumption of the TV while it is in a standby mode. So, but in the European countries, they are measured and they're as per the norms. If a TV consumes more than 0.5 watt in a standby mode, that TV will not be released to the market. So such a aggressive and stringent policies has been implemented in the other countries. Whereas in India, we are still in many of the houses, still we can find a CRT tube CRT TVs. So that consumes a huge power. So this is one of the example. And in terms of telecommunications, so telecommunications, if you see, not only starting from the mobile or the telecom towers or the telecom equipment, now we are talking about from 2G to now we are getting adapting, or one of our telecom operator is getting into a 5G network. So 4G is already accommodated with or used with many of the users. So now we are talking about 5G. That 5G, yes, when we are the technology increasing, how much power also it is getting increased. So that is if you see at present this thing, we are not only India but global companies are facing a challenge of that storage of power. So that is the which another part which is in terms of how to store or how to store the efficiently the power. So in terms of transportation, yes, transportation nowadays is plays a major role in terms of any country's growth. So like maybe in India it's a very nation stage, but other countries they're already using a hybrid vehicle. Either it could be a chargeable by the solar or it could be a power outlet charging. So they are using a hybrid. Of course, in India also one of the companies already manufactured the electric cars. So some of we can see one or two electric cars on the road, but still hybrid vehicles are very few, very few. Of course, even though we have very few, many automotive makers are working on that, and there we can future we can see the many more. And the power rating of less than 1 watt portable equipments. So nowadays if you see each and every house, at least mobiles, so many mobiles, tabs and smart laptops. So these are all the kinds of the gadgets are getting increased, so which consumes the power. And the tens and hundred watts of power supply, computers, office equipments, and like hundreds of megawatt DC transmission systems, high voltage DC and all those things. So these are all the some of the few applications which we are talking about in the industry. So the multidisciplinary, like power electronics, normally power switching technology, passive components like electromagnetics, digital electronics, control systems, manufacturing technology. These are all the technology, or these are all the these things which will power electronics will be used in the industry segment. So in the application areas like commercial, like domestic power supplies, SMPS, UPS, lighting, air conditioning, these are all the commercial and domestic IT areas. In the industrial, like pumps, fans, compressor, cranes, elevators, textile, steel industry, mining. So these are the in the telecommunication and aerospace applications. So in the transportation application, in terms of trains or locomotive, so locomotive again it starts with the locomotive traction motors, and like now old the coal engine has gone, then diesel engine, now electrical engine has come in the locomotive sector, and subways, trolley, buses, magnetic levitations and electric vehicles, automotive electronics, ship power systems and aircraft power systems. So satellite, exactly. So these are all the like, see the technologies advancing. Once we achieved one this thing, yeah, okay, next what? So how do we reduce the power consumption? How do we increase the efficiency? Or how do we increase the uh, uh, end results, how better we can move ahead. In the transportation, like if you see the picture, the hybrid electric vehicles with a much higher gas mileages, all electric ships, light rail or fly-by-wire planes, drive-by-wire automobiles. So these are all the technologies which drive systems can be used. I have some application notes exactly, particularly in the that segment. So I will in between I will switch over to that and I will explain to you. So utility systems like high voltage DC transmission, flexible AC transmissions, static wear compensation, and harmonics. Nowadays, harmonics, because we have a huge induction loads. Where the induction loads are more, obviously the harmonics are more. So how to avoid that harmonics? How to reduce the harmonics? First of all, how accurately we are measuring the harmonics. Once we measure the harmonics, how to reduce that? So that is where the in one of the Indian state, the given the given a direction to the all the industries. So your harmonics content should be is this much less than 5% or 6%. If the harmonics contents are more, then the penalty will be more, because when the harmonics is more, the power wastage is more, obviously. So keeping that in mind, so they have introduced a or appointed an agency. So that agency will go to each and every industry and it will check for the power quality. They will do the power auditing. So that report will be submitted to the respective utility like or discoms. So discom, based on the report of that third party agency, they will put a penalty, or they will give a the timeline to correct that harmonics portion. So if they're not correcting or taking an action, then the penalty will be imposed. So these are all the current day-to-day activities which is taking care by government also to reduce the power wastage and all these things. And yeah. Okay. Yeah, custom power and power quality control and supplemental energy sources like wind power, photovoltaic, fuel cells, energy storage system. These are all the technology which is available, but we are uh, very slow in adopting this our renewable energy systems. Very slow in adopting our. So our power systems like HVDC, flexible AC transmission, custom power devices, distributed generation, like flexible, reliable, and intelligent electrical energy drive systems. So these are the power systems. Definitely, one part is effective design, and the other part is after the design, how effectively that system is implemented in the field, because field condition will be different. For that field condition, how to monitor those field conditions, and for that, what will be the corrective action, or what will be the uh, uh, measurement parameter, how to reduce that effect, field effect on the systems.
You have mentioned about trends and
Yeah.
how can you contradict with smart grid?
See, smart grid, yes. Smart grid actually, it is I can say completely in terms of automated smart grid, like data from the data collection or control. So one person can sitting in a one place, so he can control the complete. For example, if I say this is a smart building,
Smart grid.
yeah, grid also, like see, now if the circuit breaker, everything is manually operated.
Monitoring, controlling,
Measurements and even
executions, all these things are done.
Data acquisition, including data acquisition, and also monitoring. For example, now if I want to go and check whether this substation, in this substation or distribution station, what is the insulation level, or what is the earth leakage level. So now I have to manually go and with the testing and measuring instrument and check and say, okay, this is the level. And if suddenly some breaker trips, so the person has to go there and check what is the why it is tripped. It could be the spike, or it could be the insulation level, or it could be the earth leakage, or whatever it is. But when you say smart grid, so all the measurement, this parameter, everything will be continuously monitored. So sitting in a control room, you know why the alarm will be popped up first. For example, any spike comes from the certain level, so the alarm will be triggered. Yes, from this line, this is the voltage which is coming up. So the spike is coming up. So immediately, so that can be spike booster or spike suppressor will be on, or if the spike suppressor is not able to detect that, also again fault level alarm will be come from the spike suppressor also. So those are the things is completely, I can say, automated. So smart grid technology is, yes, it's in a I can say it is very this thing we have I think one of our discom people team, technical team has gone to other countries to analyze countries like Australia. They've gone completely analyzed and came back, and they've sent a complete submitted a report. In one of that report, actually I'm just wonder actually what they said is it is, yes, smart grid is very good, but it is very difficult to implement in Indian system, because the major reason what they've given is, they said it is not as like our system or our environmental condition is not stable.
In Delhi, already there is implementation of the
It is there, sir. I'm see, we have not only in Delhi, many places it has been small, in a smaller level, it has been implemented, it has been successful. But when you are bringing it to a bigger level, the challenges are more. The challenges are more. See, when it is a pilot project in a small group, yes, it can be done. It is done and implemented, working fine. But when it is bringing it to a bigger level, the challenges are not like other countries where the easily it can be addressable. So of course, that is the reason government has gone one step ahead. Though they're outsourcing this kind of activities to the multinational companies who are already experienced in that segment, so that for them the basic things are already taken care. Only thing is that how they customized to the Indian environmental or Indian terrain condition is the challenge for them. So that will obviously it will be overcome.
Obviously, sir, when we left beyond 15 years back, we
Exactly.
see about SCADA and DCS.
Exactly.
That was very difficult to adopt.
Top, yes.
But nowadays, distribution companies, transmission companies, every industry
Exactly.
having its own SCADA and DCS.
Exactly.
Why? Because adaptability is there. The companies are totally trained in these fields.
Yes. And
I thought smart grid
definitely. So that is the reason now government has decided, yes, let us give this kind of contract or this kind of information to the global people, global player who are already experts in the in this, so that the basic system they knows how to customize to the Indian requirement, is that a challenge it will be easily addressed to them. So that's how it is. See, down the line, if you see, before this Delhi metro is developed, so we were metro was so, it's like a rocket science for our this one. So once now it has been foreign companies has designed their coaches or engines. Once they came in, definitely it is, now we are talking about a bullet train. Exactly. So the experts, global companies, when we open it to the global companies, so when they come in and do their this thing, definitely the possibility and the technology transfer is easy. So but it's a matter of time. Electrical drives, I'm just giving like it's a more basic. I know it's very this thing for your this thing, you already studied this. See, why I'm giving this much of basics is like, so these are all the points which is help you to measure. See, one is developing the system or simulating in the software. So but that whatever we simulate in the software, but when we put into the practical, it will not be the same as the software simulation. Okay, practically there will be challenges. So how to measure those challenges? So when we measure that, half of our job is done, because when we know, when we quantify what is the problem or what is the hurdles, so we will take an action of how to countermeasure it or how to avoid that. So test and measurement plays a very important role in any of the technology, like how to measure or how to test that. So how to quantify that. So when in olden this thing like very classic electrical drives is was a very bulky. Even now the transformers which we are talking, it's a very bulky and inefficient, so inflexible. These are all the technology when we had long back. So the modern electrical drives, I'm just giving an a comparison between the olden and the current situation. So the power in, the motor will be connected and load. So the electrical energy unregulated into regulated, and it will be connected to the motor or motor load. Or so in between, now we are talking about in between this motor, we also have a drive. So depends on the load, drive will deliver the power. So that kind of technology we are moving it now. Even VFD also we are talking about some 97, 98%. So earlier we are talking about only low voltage drives. Now we are talking about medium voltage and high voltage, as high as up to 60 kilovolt. So one of our key customer who develops the drives in the high voltage, they are using our power meter or power analyzer to test in such a high voltage what will be the efficiency. He says I'm declaring my efficiency is 98.7%. That is the highest in the world as on today. So if I come down from 98.7 to 98.6, there are so many competitors who can offer that kind of efficiency. That means 0.1% accuracy, it matters a lot. And point one, that 1% this thing, when we are talking about high voltage, it matters is lot in terms of energy losses. So some examples of like where is the constant speed and variable speed. So when you see this diagram, normally the power supply motor or pump will be divided into two valve, and it will be with the valve controller. Manually we are controlling the valve and giving the this thing. But here in the like power in will be there, and constantly, like there is no variable here. Either we can close or open. So either we can close or open, so that it's like a water pipe, big water pipe. From big water pipe we are divided, branching into two, so putting a valve. So wherever you want, you just, but it's a constant speed is constant, but we cannot vary the speed. But whereas here, so we are putting a variable speed drives. So and we are controlling through the drive, depends on the load or depends on the pump requirement. So the motor speed and this speed will be vary, so that the required amount of power will be delivered to the end usage. It's like, so one side the power losses will be minimized. If you see here the constant speed, the losses also will be the constant. It can vary, but here we are minimizing the losses as again further reduced. So the electric motors consumes more than half of the electrical energy in the US. If you say total US is country, if you take the motors alone consumes the 50% of the generation. So 50% of the generation is consumed by the motors. So then they come up with a, how to reduce that motor power consumption. So depends on the load. The best example is our elevator. So the elevator is common. If you travel 1% or 10%, if you say I can relate to the constant speed or variable speed. So if you don't have a variable speed, if you say constant speed, if you 1% travels or if the 10% travels, the same power consumes. But when you put a variable speed, if one person travels, the amount of power required to move that elevator is very small. But the 10% stands in that elevator, it requires a more power. So that energy consumption of that elevator in terms of motor is come down if one person goes and stands in the elevator. So the improvements in the energy utilization in electric motors gives a large impact on the overall energy consumption. So when we save the, depends on the load, when the energy is consumed, obviously the energy saving is higher. So by replacing the fixed speed drivers to the variable speed drives, using the high efficiency motors. Yes, if you see nowadays all BI is also talking about or come out with the highest standard or star rating for the motors also. So industrial people also talking about the high efficiency motors. So last week, last Wednesday, I read an article that one of the global company has come out with the highest efficiency motor in the world. That is of course it's manufactured in India. That is the highest efficiency. So that has been launched last week. So improves the existing power converter based drive systems. So overview of AC and DC drives. DC drives normally electrical drives that uses DC motors as a prime mover. So it regular maintenance is required. It's expensive. Speed limit is limited and easy control. Decouple control of the torque and flux. So AC drives are the electrical drives that uses AC motors as the prime mover. Less maintenance and less expensive. It's a high speed and coupling between torque and flux. Variable spatial angle between the rotor and the stator is flux. And before semiconductor devices were introduced, means less than before 1950, AC motors for fixed speed applications and DC motors for variable speed applications. So after semiconductor like IGBTs or MOSFETs are introduced, so the variable frequency sources available for AC motors and variable speed applications. So coupling between flux and torque control, application limited to medium performance applications, fans like blowers, compressor, and scalar controllers. So high performance applications like dominated by the DC motors like traction motors, elevators, servos, etc. So after vector control devices are introduced in 1980s, so AC motors used in high performance applications also like elevators and traction servos. AC motors favorable in than DC motors. However, the control is complex and expensive. Cost of microprocessor semiconductor decreases. Predicted around 30 years ago, AC motors would take over DC motors. If you see the in 1990, 60% of AC motors and 40% of DC motors. So now in 2005, that has been changed to 80%. That means AC motors utilization has been increased to 80%. So and DC has been coming down so to the 20%. So the power electronic converters in electronic drive systems, like some possible configurations, like DC motors, like we have a AC source and DC source. Again, AC drives, AC source and DC source. So AC again, AC to DC converter, AC to DC, DC to DC converter, and in DC source, DC to AC, AC to DC converter, DC to DC converter, like again AC, DC, AC, AC to AC, constant variable DC. So NCC and FCC, so DC to AC. So the converters and motors, so nowadays as I told you, like motors is consuming almost 50% of the power which is generated. So converters is playing an important role in terms of how do we save energy or efficiency that takes place. So the configuration of power electronic converters depends on the like sources available. See, if we our source, that we have to use the what kind of, whether AC source is available or DC source is available. Based on that, we have to convert it, and we have to utilize to the system what we are going to adapt. So type of motors, what type of motors we want to utilize, drive performance line applications, either it should be braking or response or ratings, and AC drives like it's for AC source application or controlled, or DC motor or brushed or brushless, and AC DC. So AC to DC or AC to DC converter for higher applications. So controlled rectifier, single phase or three phase, or uncontrolled rectifier, single phase or three phase. So DC to DC switched mode, or one quadrant, two quadrant, or four quadrant. So DC drives, if you say like a single phase, three phase, if you take a motor average, so the response time is 100 milliseconds. So, and if you see the switching waveform, so like it's a half wave rectified kind of these things. So, and if you say three phase system, so the average voltage over 3.3 milliseconds, the response over this one, and the spikes are very lesser. If you say, if it is DC to DC converter, these are the some of the analysis can be done with our MSO. We have here. I just take a little bit this thing, since we are getting into more and times of analysis. I'll just give you a brief introduction of about the common equipments which are available with Yokogawa, so that when I tell it to correlate it to here with the application, it will be easy to understand. So I'll just Yokogawa products and solution for power electronics and renewable energy applications. So introduction of our products and solutions, and application overview, and question and answers. So if you can't measure it, you cannot manage it. So anything, first we need to know what is wrong or what is right. To come to know whether it is right or wrong, first we have to measure it. Very simple, I can say, okay, TV has busted, or it's exploded. What is the reason? Whether we are getting a 230 volts or not. So any spike. So once we measure it, we'll come to know whether it is right or wrong. So if we can't measure it, you cannot manage it. Very simple as. So everywhere the testing or measuring is a very important role to understand the system and understand the behavior. So for design and debug any power systems, like we have a clamp meters, multimeter, basic. I'm just giving from the basic. So for basic instruments like clamp meters, Nikhil, multimeter. So we have a clamp meters and the multimeters. So which can so these are the clamp meters and multimeters. Multimeters will can measure, and this is the three phase clamp on meter. So which can give you the, like it will connect the voltage and the current. Okay, so single phase, three phase, our commercial utility can be measured. So these are all the numerical. And when it comes to waveform, whether it is a oscilloscope or a scope recorder. So oscilloscope, you might already used oscilloscope, which ranging from, nowadays it is available from 6 megahertz to in terms of gigahertz. But as a, in the power electronics, we don't talk about the gigahertz and all those things. So waveform and what is scope recorder? Yeah, I think you're the first time you're hearing this word, scope recorder. So it is a combination of oscilloscope and a recorder. See, oscilloscope is dedicatedly for the high sampling rate acquisition or display, and the recorder is recording the samples. So if you go for the dedicated recorders, the sampling rate is very less, like either 1 second or 2 second above the second. But when we are talking about the oscilloscope, it is in terms of nanosecond or microsecond.
Then say it as a DSO.
Which one,
Digital
sir?
storage oscilloscope.
Oscilloscope is, yes, digital storage oscilloscope.
Is this coder?
No.
Then call it.
No. No. See, digital storage oscilloscope is, that is a technology different. So not the physical storage. Okay, it's a storage behind a channel for the short movement. But whereas scope recorder is nothing but a records for a longer duration. What is the meaning of longer duration? Maybe 1 day, 10 day, month, 200 days. So we have a product which can be you can operate it and see, which can record up to 220 days. So that is called the scope recorder. When it comes to the calculations, yes, power meters or power analyzers. The power meter which displays the in terms of numerical or in terms of basic waveforms, that is called power meters. So we have a high precision power analyzers. High precision. Why it is very? If you see the tagline of Yokogawa is a precision making. So from last 102 years, Yokogawa is in the field of meters or power analyzers. So in globally, Yokogawa is the number one. We have a more than 70% market share in terms of power analyzer. The rest of the 30% is shared by many other competitors. So we have more than 70% market share in terms of power analyzer. You go to any industry, starting from the bulb manufacturer to the UPS manufacturer, system manufacturer, any power condition, or your turbine or boiler or engine manufacturer, they are using the Yokogawa power analyzers. And power scope. So I think scope recorder and power scope. So it's like a new word. Power scope is like a oscilloscope function and power analyzer function. It's a combination of oscilloscope and power analyzer function is built into the one equipment that is called the precision power scope. So Yokogawa is the first people to launch the first scope recorder and the power scope. So for the basic measurement, basic is nothing but like our voltage, current, and frequency are basic parameters. So for we have a digital multimeter, that is TY series, and we have a single phase, three phase power meters. So this is basically for the commercial frequencies like 50 hertz and 60 hertz, where the utility or in the industry, I can say, or in NITTR maintenance department, if you go, they'll just talking about only 50 hertz. Incoming from the electricity board is 50 hertz or 50 to 60 hertz, and distribution to the all the building is 50 hertz, 60 hertz. So this kind of power analyzers are more than sufficient to cater for the 50 to 60 hertz requirement. And clamp meter, so to measure the currents from the leakage 1 milliampere or 1 milliampere to the 100 amps, 2000 amps, 3000 amps, we have a CL series clamp on meters. So insulation testers, yes, insulation testers in, in terms of distribution switchyard or transmission switchyard is a very important parameter to be keep high insulation. So so we have an insulation tester and earth testers. So you know when we are at home, when the building, if it is not properly grounded or heard, so the current passing through the human body is risk that chances are high. So we normally don't see such importance. We don't give much importance to the earth or earthing. So, but it is a very critical parameter. If the building or if the any appliances, or if that is the reason normally people recommends to use 3-pin plug or 3-pin. So that is always safe, because even in any leakage current or passes through, because even a 10 milliamps current is more than sufficient to give a shock to the any human body if it pass through. DC is more predominantly very dangerous. So we should not take a chance. So that is the reason we always either at home also or at any working place also, we should be very cautious about the grounding or earthing point. Some common problems of multimeter users. So it's a not only like it's a uniform waveform. Sometimes, like if you're talking about a drive system, it will be a pulse width modulated waveforms. So it's not a 50 hertz or 60 hertz. It is, if the harmonics are more, instead of sine wave, we'll get a square wave. So those are the dealing with the non-uniform voltages and worried about wrong connections. Okay. See, normally multimeter, why it goes bad? See, we have a dedicated voltage and current terminals. Okay, dedicated current terminals and dedicated voltage terminals. Why it goes bad? By connecting the voltage terminal or by connecting the current terminal, feeding the voltage. By doing the wrong connection, so normally the voltage or multimeters goes bad. So if you see this, when we turn on, when you go to current measurement terminal, measurement only, this current shutter will open. Okay, when you come to voltage, so this will get closed. So that means when you're measuring voltage and ohmic value, so whatever the plugs which we need to connect it, that will be opened. So when you want to measure the current, so these current terminals will be opened so that you can use the current terminals. So here you need not have to worry about, okay, I will connect it to the current, I will feed the voltage. So then that multimeter will go bad. So that this kind of safety precautions is essential. And accidental errors like falling down, or you see, nobody does intentionally. Sometimes while working or turning or taking while going taking lifting out, so it may fall down. So writing down the readings. So many nowadays, of course, in the labs or college labs is not a big criteria, but when in the industry, so writing down the readings when we are taking a more number of this thing is very difficult. So we have a optocoupler which can communicate through the USB cable so that all the data can be logged to the PC. So it's having a around 600 data or 1600 data can be stored inside the multimeter. That is the one option. So you need not have to write down. And the second option is you can communicate to the PC at a regular interval. You can log the data. So it will pull the data to the PC with the communication port. So these are all the normal or common problems which multimeter users faces, either in the industry, either in the lab. See, normally, yesterday I had been to one of the IITs. Okay, the professor told that give me a low cost multimeter. I just asked a simple question, madam, you are the highest education institute in India, and you are asking for a low cost multimeter. Can I know the reason? Madam told that my students are not enough or well educated to use the multimeter, so the chances of going bad is high. So that's why I am purchasing a low cost. Then I told, see, we have given us so much of safety precautions. Even after it goes bad, it is not the problem of the equipment, it is a usage problem. Like the person who was using is not able to sorry, understand the equipment. See, yes, basic this thing, it will equipment will give the direction. Okay, when you're using voltage, you have to use with this. When you're using a current, you have to use this. For data logging, you have to use this. So these are all the minimum requirements or safety precautions one company can expect. And at the same time, the minimum education also should be there to the user. So by combining that, definitely we can make utilize of this equipment more effectively. And we have also given that like it is a 3 years warranty. None of the other customers or other competitors gives the 3 years warranty. So even for a multimeter, which costs starting from 5,000, 6,000 rupees, so nobody gives the 3 years warranty. Nor our mobiles companies gives the 3 years. So maximum is 1 year warranty. So that's why we call this is a mistake-proof multimeter. So high safety and high precision multimeter. So true RMS measurement can be done. So any waveform, so true RMS measurement can be done, and PC connectivity for data logging, and high impedance protection for voltage and current differences, and current protection shutters, and elastometer enclosed and drop tested. Up to 2 meter, it has been drop tested. Up to 2 meter, if accidentally falls also, it is tested for that up to 2 meters. And frequency filter for VFD measurement for to eliminate the high frequency components. So this is a mistake proof multimeter. So whatever the normal common mistakes which happens in the industry or in the users, so that can be avoided with the multimeters. So in the same manner, what are the basic I'm talking about basic level equipments. So in the basic level, again, harmonics measurement. So true RMS measurements. So inrush current measurements and VFD measurements. So harmonics measurement is not a easy thing in this thing, but yes, it is a critical parameter in a AC system to measure the harmonics. Because harmonics, the contents of the harmonics is higher. Obviously, as I told you, it is the losses are also will be higher side. And inrush current, if you see any motors, when you switch on the motor, the starting current will be higher side. So that is called the inrush current. So that measurement is also a critical parameters. And the VFD measurement. So VFD measurement normally depends on the load, the frequency modulation changes. So depends on the load. So that variable frequency drive, so that measurement with at what frequency, because in that the pulse width modulated waveforms are incorporated in the drive system. So that depends on the load, the pulse width will be modulated and the respective power will be transmitted to the load. So all in one, it is possible. This is a single phase power meter. This is a single phase power meter where you can measure the voltage and the current up to 600 volts and up to 1000 amps. So up to 600 kilowatt you can measure the power with a small equipment. And you can, if you see here, you can measure voltage, current, wattage. So ohmic value and so all the DMM functions can be measured here, and the power measurement and motor inrush current. So harmonics up to 25th order. So cat 4 safety up to 600 volts. So true RMS measurement. So for the single phase applications, really it is a true troubleshooting equipment, true troubleshooter. So when it comes to waveform analysis, so okay, let us move on to the waveform analysis. So waveform analysis products normally, as the name says, it is a acquiring the waveforms data. So we have a DLM series. So it's a mixed signal oscilloscope. The name itself says it's a mixed signal. So mixed signal means analog plus digital signals. Dono can be like both can be both can be seen in a same display. So we have 4 channel, 2 channel, 4 channel and 8 channel mixed signal oscilloscopes. So this is a basic level or entry level oscilloscope, like the 4-channel best in class 4-channel mixed signal oscilloscope. The features and the bandwidth 200 megahertz or 350 megahertz or 500 megahertz. It can be configurable for 2-channel or 4-channel. The 2.5 gigasamples per second. So up to 8-bit logic channels. So up to 250 megapoints memory. And the serial bus analysis like I2C, SPI, CAN, LIN, ORT, FlexRay. So these protocols for decoding these serial buses are available. And power supply analysis function, and it's having a wide 8.4-inch high resolution display. Okay, these are the key features of this equipment. So we have a DLM 4000 series equipment. In that it can be configured up to 8-channel. So the first 8-channel mixed signal oscilloscope in the market. So basic 2.5 gigasamples per second rate, sampling rate, up to 24-bit logic channels. So bandwidth of 350 megahertz and 500 megahertz. So up to 125 megapoints memory. So again, same serial bus analysis like I2C, SPI, CAN, LIN, UART, and FlexRay analysis, and power supply analysis function. We have a 12.1-inch high resolution display. So the silent features of this DLM 2000 and 4000. Normally, any oscilloscope or any mixed signal oscilloscope or digital storage oscilloscope, normally if you say a bandwidth of 100 megahertz or 200 megahertz or 500 megahertz, when we are talking about a higher side bandwidth, at the same time, it is important criteria that okay, in the lower side how much we can analyze. So we at current situation we cannot have two oscilloscopes, one for lower signal, one for high end signal. So when we are when we are talking about a power electronics or power devices, semiconductors, so the frequency will be in terms of kilohertz. The operating frequency of a semiconductor devices will be in terms of kilohertz. When we have a megahertz or 100 megahertz or 200 megahertz or 500 megahertz oscilloscope, how do we analyze the kilohertz signal? So that is a one question normally, which yes, we can manage with the lowest bandwidth which is available in the market. It is 20 megahertz. Even though you have a 200 megahertz oscilloscope, the bandwidth limit can be bring it down up to 20 megahertz. Okay, but 20 megahertz again further if you want to analyze in the 1 kilohertz or 2 kilohertz signal or 5 kilohertz signal, so 20 megahertz bandwidth and 5 kilohertz signal, the depth of the analysis or the sampling points is not so great to get a complete or capture a complete information of the kilohertz signal. So what is the main function is, see, our bandwidth limit, the only company which provides the lowest bandwidth in terms of lower side is up to 8 kilohertz. So you can bring it or you can limit the oscilloscope bandwidth as low as 8 kilohertz. So from 200 megahertz to 8 kilohertz you can bring it down. So that is a one key parameter when we are working in a power electronics. And linear scale and measurement display of 20 measurement display simultaneously. For example, if you see here on the screen, when you make a display of the on the screen, so in any waveform, so up to 20 numerical signals. So you can see, like you can calculate peak to peak or RMS voltage or frequency or Like that, up to 20 measurements you can simultaneously see on the screen. And calculated measurements, like if you want to calculate the trace A minus B or trace A plus B. So if you want to calculate the measurements, 4 measurements can be simultaneously calculated. So this is the formula which you can see in the, like you can put a arithmetic or any logarithmic formulas. And n single option. So what is the n single option? N single option is a where you can single triggering. You might be knowing that single triggering option. So single triggering means you will set the oscilloscope in such a way that it will be keep waiting for any abnormal signal. Okay, single trigger means only once. After that, oscilloscope will come to a halt mode. But whereas in n single, you can define that number n. Only one signal or 10 signal, 20 signal, 500 signal, 1000 signal. If it is a repetitive signal, so you can set the n number. So it will waiting capture one on the other. It will waiting for the capture those as the limit you set. Okay. So for example, if you don't know any parameter, like if you want to analyze some 10 signals which is abnormal in your power supply, so connect the oscilloscope and set the n signal as a 10. So it will capture the 10 different events that which comes. So and you can analyze the post analysis. So memory segmentation and history function. So normally you can why memory is so important. See, when you say giga samples, 2.5 giga samples, so optionally you can go up to 125 megapoints. Okay, that is a memory what we can give. So behind each channel, when you want to acquire the more samples, so obviously you can segment your, or you can define your memory. So in behind each channel, so that that data can be acquired, and the more post analysis will be easy. And history function, automatically equipment as a history function, like it can take up to 10,000 screens in the backside, so that you can recall that like in your mobile phone, and you can check those functions. So you need not have to set anything, automatically it brings to the history. So last 10,000 frames. So dual zoom, so you can zoom a signal and again further it can be zoomed. So dual zoom is possible. And dual FFT, frequency fast Fourier transformation. So dual FFT, dual XY. Normally in normal MS, you will have one like single zoom FFT and XY display, but here you have a dual, both all the two functions simultaneously. And you can plot a trend or histogram measurement display. And action on trigger, so in particular action you can set, like if voltage goes more than 30 volts or 40 volts, so you can set the trigger levels. So if that signal goes to that particular this thing, it will capture. So that is the action on trigger. So these are all the silent features of the our oscilloscopes, DLM series oscilloscopes. So next we are moving on to the sorry.
Measurement display.
Yeah. You want to show? Yeah, we'll when come to practical session we can see. Yeah. Thank you. So and DL 850, as I told you, the scope recorder, it's a combination of oscilloscope and recorder. So we have a dedicated oscilloscope and dedicated record. By combining the oscilloscope and recorder, it is a scope recorder. So what is the features of this scope recorder? Scope recorder is a powerful, portable data acquisition recorder that can capture and analyze both transient events and trends up to 200 days. So it can like 100 mega samples per second sampling speed. Up to 128 channel you can configure. Up to 128 channel. 10 nanoseconds to 200 days recording capacity. High speed glitches can be captured. Many triggers. So different type of triggers are available. AC voltage and current can be measured. Millivolt to kilovolt. So directly you can feed, no need of any probes. Directly up to 1000 volts, 1 kilovolt you can directly feed to the equipment. So it can also not only voltage and current, it also can measure temperature, strain, vibration, acceleration, and frequency, many more parameters. And moreover, it can do the waveform analysis. Normally, if you see the recorders will have a sampling of like 1 seconds, or best recorder which is available is 500 milliseconds. But here we can have a 100 mega samples per second. So if you see the right side panel of the equipment, yeah. If you see the right side panel of the equipment, so it's a 8 slots. So 8 slots can be accommodated 8 modules. So it's a modular platform. So you can choose the module based on your application requirement, either voltage, current, acceleration, strain, frequency, temperature, whatever it is, you can choose the module as per the requirement. If you see here, this is a temperature module. These are all the voltage modules. So each module contains 2 channels. So there is a one more model which contains 4 channels. So if it is a 2 channel module, 8 into 2, 16 channel. If it is a 4 channel module, 4 into 8, 32 channel. And this is a temperature, it is a 16 channel. So if it is only a temperature, up to 128 channel. So depends on your application. You can configure the equipment, and it is not necessary that all the modules should be present. This is the main frame. You can start working with a 2 channel or 1 module. So later on you can buy only module and you can start upgrading it. Depends on the requirement. Like vibration module also, acceleration module also, or the temperature module. One module you can buy and you can insert it, and it's a art swappable. So the equipment is capable to automatically detect the module and it will give you the result. And it's having up to 128 channel and 100 mega samples module. Logic channels also can be put in, and best noise immunity. It will suppress the noise, surrounding noise, and the backward compatibility. Like earlier we had a 750 DL 750 before coming to DL 850. Those modules can also be used in this. That is called backward compatibility. So if you see the right side panel, so you have a USB for remote control and file transfer and mouse keypad. You have a USB port to control the equipment. Also you can connect it to the PC, and you have a Ethernet port, okay, where you can configure or you can connect it to your network, and you can control it from anywhere in the building through IP address. You can configure the IP address. And we have a eSATA port which you can connect the external hard disk. So the beauty is, normally any equipment you can store the information and you can transfer it to external hard disk. But whereas in this equipment, you can directly write all the information to external hard disk without storing the internal hard disk. So that is the beauty of the equipment. And it's having a VGA port where you can connect it to the external monitor or and SD card slot. Many industries normally they don't allow pen drives, storage devices due to security reason. So there you can use the SD card, like our mobile memory card. So you can use a SD card where you can record the data. So this and up to 32 GB. So it's having all the latest communication ports, including GPIV and Ethernet, all those things. So and also GPS can be configured. You can connect the GPS device and it will detect the location and it can be configured. We have a vehicle edition. Vehicle edition means it will give you the it will analyze the vehicle buses, serial buses, so that you can decode that and it will be it will easy to carry along with the vehicle, so that it's having, like, for example, any car maker, automotive maker wants to test their car before releasing to the market. So what will be the engine vibration, temperature, surrounding temperature, and what is the RPM. So everything they want to monitor and record it. So this can be fit into the vehicle. So there is a 24 volts DC power supply where car battery output can be connected as a power supply, and it will start acquiring the data. So this we have demonstrated in one of the Bangalore Metro Rail also. So where all the parameters can be captured and it can be post analysis can be done. So this is a very I can say it's a problem solver. Any what is parameter can be recorded or transient can be captured. Okay. So 17 unique models, different kind of 17 modules are available to combine measurement, electrical signals, physical sensors, and CAN-LIN bus, and expandable up to 128 channel. So maximum sampling rate is 100 megasamples per second. 2 gigapoints of internal memory plus real-time streaming to internal or external hard disk. Various types of inputs like voltage, current, temperature, acceleration, strain, frequency, speed, distance, pulse. Customized CAN-LIN. Real-time mathematical and waveform analysis for power applications. So DL850 EV vehicle edition for engineers in the automotive and railway industries. USB, GPIB, Ethernet, iRig, and GPS interface options. So it's truly an application solver. So this is the first in the industry where the scope coder has, and if you see all IITs, NITs, and automotive, and many, you can say any application, definitely it can be connected and analyze the data. So accessories like passive probes, 1x, 10x, 100x passive probes, isolation probes 10x, 100x, active probes up to 1.5 gigahertz, differential probes, clamp-on probes up to 3 kiloamps, current probes and up to 500 amps, and logic probes, and digital isolation contact type or non-contact type probes. Okay, comes to measurement, power measurement. So as I said earlier, Yokogawa is the pioneer in the power meter or power analyzers. So for all applications, starting from the basic applications till the R&D application, we have a variety or different models of power analyzers, starting from single phase. So single phase 20 amps and 40 amps direct input. Okay, or if you want to measure more than 40 amps, you can connect through sensor or CT or Hall effect sensors. You can connect it to the equipment and you can measure up to kiloamps. And harmonics up to 50th order. You have 3-phase power meter, WT330 3-phase power meter, 20 amps direct, and as per the probe selection or CT selection, you can go up to higher side, and harmonic analysis up to 50th order. You have WT500, which again 3-phase, 40 amps direct current, and harmonic analysis. The difference between WT300 series and WT500 series, WT300 series is a LED, 7-segment LED, numerical data, whereas WT500 is a LCD display where you can see the waveforms, what kind of waveforms, vector diagrams. So when it comes to high-end power analyzer, high precision power analyzers, we have a WT300, sorry, 3000. This is the world best accuracy power analyzer which is available in the industry now. So 0.01% of the basic accuracy, 0.01%. This is the best power analyzer which is available in the market now. And bandwidth up to 1 megahertz, 16-bit high resolution, and 200 kilosamples per second. Current range up to 30 amps direct current, but through clamps or CT you can connect up to kiloamps or kiloamps as per the CT's availability, and up to 100th order harmonics, and new motor efficiency. That means motor efficiency, it can take the input of the speed and torque signal, so it can calculate the mechanical power. So electrical power to the input to the motor, output of the motor in terms of speed and torque, so it will calculate the mechanical power, so it will give you the efficiency of a motor. So output by input, mechanical power divided by electrical power, it gives the efficiency. So all the latest connectivities like USB, RS232, GPIB and Ethernet. So world best power analyzer in terms of 6 element. So one equipment, it can take up to 6 elements. Why 6 elements is required normally? See, normally we have a 3-phase, maximum 3-phase. Why 6 element is required? For example, if you want to calculate an efficiency of a motor, 3-phase motor, or if you want to calculate a 3-phase inverter efficiency, obviously input output has to be connected, output by input. So 3-phase for the input, 3-phase for the output. So 6 element. So each element will be acting as a channel or one phase. Okay. So each element or each channel will be configured for the one phase. So 3-phase input for the 3-phase output. So 6 element, 0.05% basic accuracy, up to 500 bandwidth, 16-bit high resolution, 2 megasamples per second. And it can go up to 55 amps direct input, of course higher current through CTs, and the harmonics order up to 500th order harmonics. Motor efficiency, again it can take motor input, connectivity, GPIB, USB and Ethernet. This is how the back panel shows. So you can see the 6 elements. So each element will be each channel. So these are all the voltage input. These two are the current inputs. So voltage and current. So if you are connecting through CTs or Hall effect sensors, so this BNC connector will be used for the. So this BNC connector, normally Hall effect sensors will give the voltage output. For example, 1 millivolt per ampere or 10 millivolt per ampere. So it will give you the voltage output. So voltage output can be connected to through this BNC. So this is the motor input module. So it will take speed and torque. So torque and speed of A, B, Z, all the 3 signals. So it will calculate the mechanical power. And this is the GPIB port or digital to analog output port, Ethernet port, VGA port, and USB port. So power scope. Power scope, it's a model called PX8000. It is the precision power scope. PX8000 brings together Yokogawa's world-leading expertise in the power measurement with our long heritage in the oscilloscope design to deliver a true test and measurement revolution, the world's first precision power scope. So it's a combination of scope coder and power analyzer. So it's a power scope. So this is a front panel. So this can configure up to 4 power channel. So one module will be voltage and another one will be a current. So it is calibrated as a one set. So one voltage module and one current module is calibrated as a one set, so that it will be served as a one channel. Okay, so like that it can be configured up to 4 channel, and it's 100 megasamples per second module. Auxiliary input, it can take up to 20 volts, noise immunity, and 20 megahertz bandwidth. So normally if you want to go with a high switching and this thing, so 20 megahertz, it can go up to 20 megahertz. Now we are all talking about the wireless charging for automotive applications or for our mobile applications. So just if you keep the mobile phone on the wireless charger, so with the electro induction method, it will get charged. So it requires a high bandwidth for the power applications. So this power scope will be used, and nowadays this automotive applications for like wireless charging. So for that kind of design, automotive design and wireless charger design, this power scope will be predominantly used. Similarly, this having like USB interface for file transfer, remote control, mouse, keyboard, and gigabit Ethernet interface, and VGA output, SD card slot. So the variety of current sensors. Normally, when we say we have a high accuracy power analyzers, similarly we should have a high accuracy current sensors, because if the current sensors is a low accuracy, even though if you have a high accuracy power analyzer, it will not be any use, because when the sensing part is low accuracy and measurement part is high accuracy, so then our purpose will not be solved. So we should have a high accuracy sensor as well as the high accuracy power analyzer. So then only we can more precisely. We can measure more precisely. CT60, CT200, CT1000, it is like 1000 amps, 200 amps, 60 amps respectively. You can measure up to 1000, both AC DC, like up to 500 kilohertz or 800 kilohertz or 300 kilohertz, like that. And it's not only that, any other manufacturer CT also can be configured. Some of the application, now we more or less we got an idea of what kind of equipments we have in the.
Can a current sensor be plugged into this power scope?
Current sensor? Yeah, you can. See, current sensor normally, there are 2 types of sensor basically. One is it will measures the current and gives the output as a current sensor. Current as a current output. Another one is it will measure the current and gives the output as a voltage, in terms of voltage. Okay, so if you're directly connecting the current, means primary is current, secondary is also current. So that means you can give it directly to the current terminal. Okay, so if the CT or current sensor output in terms of it's a millivolts, you can give it to the auxiliary sensor input, so that it will accordingly, for example, your voltage millivolts output will be like 10 millivolts per ampere. So that millivolts output, if you can give it to auxiliary input, so it will give you the equipment. You have to set a ratio, like 10. If it measuring at 10 millivolt, it will be converted into equal 1 amp. So automatically equipment will convert that ratio, and it will give you the exact measurement of what is the current flowing through the circuit. Okay. Before going to this application, I have one dedicated application presentation. For specifically for the power measurement for photovoltaic power generation. Okay, maybe we can discuss in detail here, like requirements for the power measurement of each section, level converter test in the R&D, power conditioner efficiency and evaluation in the R&D, power quality evaluation for AC output voltage in R&D, protection functions test for grid connection, protection function test for like anti-islanding in the section, power conditioner system evaluation, and power condition in the designing and QA, battery charger and discharge characteristics, power conditioner evaluation. This more predominantly focusing more on the power electronics applications. For example, if you say R&D and QA, so the requirement will be voltage, current, power, efficiency at high accuracy, power quality, like protection test, like first response, all those things. So when you have a circuit DC to AC converter or DC to DC converter, so it can be connected to a equipment where WT3000. So input will be a DC, output will be a AC. So, and if it is according to the channel, I think you remember the channel which I have shown, like 3 channel or 6 channel. So each channel will be like DC means one channel is sufficient. AC means if it is a single phase, again one channel is sufficient, or if it is a more than 3 phase means 3 channel is required. So it will calculate with a high accuracy, bandwidth and update rate 50 milliseconds. See, normally other power analyzers will have like 1 second and 500 milliseconds update rate, even data capture. See, if you want to capture a fast response like or a transient waveforms, so even though if you have a very good power analyzer, if you are not able to capture the data with a lesser interval, you will not be able to see the what is the transient or what is the spike or whatever it is. So it is update rate is also equivalent important, plays an important role in terms of acquiring the data correctly. So that is the this is the application. And when it comes to component level, when it comes to power conditioner system, again the power quality like DC to AC, so 3 phase WT1800 can be used with a multiple like a 3 phase input or 3 phase input and 3 phase output, and with a high accuracy. And WT1800 can go up to 5 milliseconds data capturing. So that means in a second, 200 data can be captured. Per second, 200 data can be captured. So that even in the solar application or photovoltaic application, maximum peak power transfer. So that graph can also be plotted. And for commercial products like home appliances or other things, WT500 with a lower accuracy or medium accuracy is sufficient with a component or commercial frequency with 100 milliseconds and up to 3 channels. So this is one this thing. Any questions in this slide maybe? See why we have used different equipment. Sorry. You want to enlarge it? Okay, which portion you would like to see, sir? Factors, okay. Oh, sorry. This one? Oh, sorry. Okay, R&D again, like voltage, current, power, efficiency at high accuracy, power quality, production test. The R&D or QA in the power conditioner system, like efficiency with multi-channel. So if you see here, multi-channel. So here input is DC single channel, output is also AC single channel. Here DC input 3 channel, 3 phase, and AC also 3 phase. So 6 channel is required. 6 channels are required. I maybe I can ask. Okay, I have a three channel equipment. Okay, I will use 2 equipments, one for the input, one for the output. So obviously my purpose is served. Is it a right method?
No, sir.
Why?
Reason is the precise measurements, because at the same moment the observant cannot be go to the first and second
Exactly.
at the parallel time.
Exactly. It's a matter of timing.
Definitely.
See, when you're using a 2 equipments, okay, both will work in a different time.
Definitely.
Time it for us may not be visibly seen the different timings, but the crystal frequency or internal clock frequency which is working with the one equipment, the other equipment is totally different. Okay, when you're calculating an efficiency, so that timing, if the timing is not good, obviously you don't get the exact or good efficiency. So that is the reason the equipment is available with a 6 channel. So one equipment can calculate the, because that will works with the same frequency, at the same time it will calculate the input and output. So you will get a,
Around the points the clock frequency will be the same,
yes,
and obviously the resultant will be
exactly same. So that is the reason. See, many people, yes, I have 2 3-phase equipments, I will use one for input, one for output, I will calculate the efficiency. I practically I have seen in the industry people have did that, and when it goes for the authentication or it in the certification level, it has been rejected.
That's why 2 channel CROs are there, 4 channel CROs are there,
And
that's
8
why
channel.
they are being commented.
Exactly. So that is where we need to understand, and sometimes we have to educate also. See,
And what about this WT 500? The last 3000 is okay, 1800 is okay. WT 500.
WT 500 is a 3 channel.
Why this is being used? In spite of services being met for 3000 and 1800.
Okay. Yes. Exactly.
And if you see the accuracy of WT 1800 is 0.05%, but the accuracy of WT 500 is 0.1%.
1%.
So sometimes you don't require so accurate also.
I'll give you one example. We have a distribution transformer. We have a power transformer. Distribution transformer, low voltage, low current. Power transformer, high voltage, high current. Okay. So when I use a WT 3000 in a I'll go with a WT 500 with the distribution transformer and power transformer. 0.1% of 440 volts, somewhere around 0.44 volts, 0.4 volts. And when we are talking about a power transformer, it's 11 kV or 16 kV, 0.1% of 11 kV. 110 volts. So here the variation is minimum. Here the variation is very high. 0.1% of that 11 kV, 110 volts is a huge. So there, if I use 0.01% accuracy, it is 1.1 volts. Even though we are measuring 11 kV, so the variation is only 1 volt. 1 volt. So here our for 440 volts, and when we use 0.1% accuracy, 0.44 volts. So that is where it depends. And similarly the losses also, if you say 5% loss in the distribution transformer, it's almost 2 volts. If you say the same 5%, if you take it in the power transformer, it will be 500 volts. So for 11 kV or 11 kilowatt power, 5% means it is huge. 0.5 kilowatt, 500 watt means 0.5 kilowatt. It's a huge. So obviously we need a better accuracy measurement. So here the important is the selection of the right testing equipment is very critical. Okay. See, now we know like our mobiles are available from 1000 rupees to 1 lakh rupees. Okay. Depends on our requirement, our application, how many applications I use at a time. Will I use email or will I use only? So even if you buy 1 lakh rupees mobile and you will be using it only for the voice calling, what is the use? So we have to see the criticality, application, how important that will affect my costing and my application criteria. So these are the points which we need to think before going to any test and measuring equipment selection. So at the same time, for the commercial converter, like commercial product like our mixer, grinder or refrigerator, even if it is a 1% variation, it doesn't matter. 1% variation or 1% accuracy doesn't matter. So hence, so we can aram say use WT500. So when it goes to R&D, like sometimes we have in WT1800 we have a fantastic feature. It's a filtering. Okay, line filter and frequency filter. So when I'm designing a inverter circuit, okay, when I like I want to, so in that PWM signal, in that pulse width modulated signal, I want to see what kind of reaction when it comes when we put a different kind of filters at the output side. So we have a feature in this, every 0.1 hertz you can vary the filter. See, one is filter on off. I have a 1 kilowatt signal or 1 kilowatt filter. So I can make it on or off. So that will give you idea of, okay, with filter what is the result, without filter what is the result. But when I have an option of varying the filter frequency with a 0.1 hertz resolution, definitely I can think better, okay, at 50 hertz or 51.5 hertz or 50.6 hertz. So if I vary the filter, so this will be the output. So that kind of R&D applications, yes, it requires a detailed analysis or detailed setting of the equipment's parameters or the filtering options or the boosting options is required. So those parameters also has been considered in the equipments. So level converter test in the R&D applications. So this side is anyway, photovoltaic side is only a DC, whatever comes from the solar panel. From the others, again inverter, from photovoltaic to inverter. So in between we have a converter. So what is the converter efficiency? So we have a very high accuracy WT3000 which can measure or measure the DC versus or AC divided by DC. So with a 0.01% basic accuracy, so it will high accurately. And okay, what is the meaning of null function to reduce the offset error? So normally any test and measuring equipment will have a internal offset because it's an electronic equipment. All the it consists of so many passive and active components. It will have its own offset or its own noise or its own errors. So null function, it will give you, it's like a setting those null function as a reference. That means that will become a 0. From that 0, what is the efficiency? So that will give you additional one step ahead to calculate the efficiency more precisely. See, if you don't enable the null function, that additional offset also will be added to the input side or output side. So that will give you the either positive side or negative side efficiency. It may affect in both the side. But when you enable the null function, so it can be avoided. So that will become a 0 point. From that 0 reference, what is the efficiency? So high power conversion efficiencies is most important feature. This measurement requires highly accurate power measurements. So if you say the DC power supply, so we can connect voltage 1 and current 1. So this is the first channel, okay, and this is the inverter section, and this is the filter section, this is the protector section, and output is a 3-phase. Again you can see the delta connection, okay, voltage 2, current 2, voltage 3, current 3, and voltage 4, current 4. So here for efficiency measurement, accuracy of 0. Like basic power accuracy up to 4 element. So simultaneous measurement of THD. What's the meaning of THD? Total harmonic distortion. So total harmonics distortion is derived from the individual harmonics. Okay, sometimes third harmonic will be higher side, or fifth harmonic will be higher side, or 11th harmonic will be in the higher side. So the designer will get the idea. This may give the total harmonic distortion. So what is the individual harmonic? What is the first harmonic's voltage level? So what is the first harmonic current level? Sorry. So individual harmonics is also possible. Individual harmonics analysis, either in terms of bar graph or in terms of waveform. So you can see the waveform also or the bar graph also, and you can identify what kind of harmonics you need to eliminate it. And see, this can WT333 can go up to 50th harmonic, WT3000 can go up to 100th harmonic, WT1800 can go up to 500th order harmonic. So normally if it is an inductive load, the harmonic content will be high, even sometimes 100th level or sometimes 150th level will be there. So if in the resistive load, harmonic contents are less. So you can see the depends on the loading, you can analyze the harmonics. So accordingly you can take it. So this in the either in the numerical format or in the graphical format, you can take the pictures or you can get the report. So this data can be either saved in the numerical format or in the waveform format, so that can be reproduced. We have a free software which can pull your data into your PC for the post analysis. So the same data can be saved into CSV format, and then it can be post analysis can be done. And fast update rate up to 50 millisecond. See, one of our customer like one of our customer company called Schneider Electric. They are the pioneer in the solar inverter design. They are using our WT1800. Their one of the requirement is, I want in a day from morning 6 o'clock to evening 6 o'clock. I want to plot a graph how the solar panel has been absorb the light and given the maximum power. That is called MPPT, maximum peak power transfer. Okay, so it's a collective data, and with that you can plot the graph. So that requires a high sampling data. Okay, in a complete day. So that means 50 millisecond or 5 millisecond. It can go up to as low as 5 millisecond. So here it is mentioned only 50 millisecond. We have an option called HS option, high speed data capturing option. So that can go up to 5 milliseconds. That means in a second, 200 data can be pulled. Okay. So with that help of that 5 milliseconds, so it is easy for plotting the graph more precisely. And power quality. Well, the quality nowadays, there are so many quality standards in place. So now Bureau of Indian Standard has made a restriction that if any battery or any AC adapter, if it is not BIS approved or Bureau of Indian Standard is not approved, we cannot import it from any country. It is a very stringent Indian standard which they have imposed recently. Recently means in a year back. Okay, so any foreign country which they want to sell their adapter or battery to India, it has to be BIS approved. So what they talk about in that standard is the stability and the protection and the quality of the power, constant delivery of the power. So if it is meeting, BIS will give the their approval to import it. Otherwise, they don't give. So that is now the power quality, and also nowadays the quality consciousness is growing in all the industry segment. As see, because the power crunch is there, power demand is growing every day. At the same time, the consumption is also growing, but of course our government is striving to fulfill the demand, but still the demand and supply gap is getting increased, our power generation. So we are all focusing on how to save the energy or how to minimize the consumption. So in terms the quality norms, so industries, they're using the almost 50 to 60% of or more than 60% of the power generated is consumed by the industry. So industry means obviously there are motors will be there are pumps will be there are so many equipments, heavy equipments are there, so that consumes a huge power. Okay, if the load is not balanced, if the in an industry, if the load is not balanced, obviously the power factor will vary and the power consumption is high. So as I told you earlier, government is imposing all the industries to get the quality of audit, power audit at least once in a 6 months. That is, they have made it as a mandatory. Okay, every 6 months once they have to undergo the power quality audit. Okay, and then they should supposed to keep all the records. In that any variations, this thing they have to take immediate action so that the power can be minimized. So power quality as per nowadays IEC 6000, iPhone 3, iPhone 3 or iPhone 3, iPhone 4, iPhone 3 and 5. These are the some of the IEC standards which we are talking about quality of the power. Of course, our WT 3000 or WT 1800 are almost compliant to that standard from long back, because in the other countries which they are already following those standards. If you see the power quality evaluation of an AC output in the voltage industry, I think it's not visible here. I'll just zoom it. This is one of the screenshot of in the power analyzer. Like it is measuring the voltage of a channel 1 like 103 volts and current of around 600 milliamps. And if you see this is the table of the harmonics contents, like first, second, third or fourth, like that. So it keeps moving. This is the voltage harmonics, this is the current harmonics. Okay, first one is the fundamental frequency, and the second one is the second harmonic, third harmonic, fourth harmonic. Similarly, if we see here, the current third harmonic is very high, and in the voltage seventh harmonic is very high. Okay, 1.7 volts, and here the current is third harmonic is 143 milliamperes. It's almost 1/3 of the total one third of the total current. Okay, so that, sorry, so if you see the harmonics, this is the voltage total harmonic and current total harmonics. So obviously we can see the current harmonics distortion is almost 24.88%, and the voltage harmonic distortion is 1.74%. Okay, so this is the, we are talking about the input section. So this is how we can analyze the individual harmonics as well as the total harmonics of any particular power system. So this is in the numerical format, and if you come to the graphical or bar graph format, you can see here, this is the bar graph. So yellow color is the voltage harmonics, and we have seen like voltage 7th harmonics is the highest one, and the current 3rd harmonics is the highest one. Similarly, we can see the bars, the bar graph in the 3rd and 7th harmonics in the highest side. The bottom one is the power harmonic, voltage harmonic, current harmonic, and the power harmonics. Okay, this is the total harmonics display up to 500th order. This represents up to 500th order. So as on today, the WT1800 is the only equipment which can give you the detailed analysis up to 500th order. And as per the IEC standard, conformity to the IEC test of harmonics, harmonics also international IEC standard, IEC 61000-3, 2 and 312. So these two standards defines the harmonic. Okay, 3000 can measure voltage, current, power and harmonics simultaneously. So as per the IEC standards. So there is a one more option, like the limits is like THD is less, it should be less than 5%, harmonic should be less than 3%, harmonics order should be 2 to 40, more than 40 there should not be any harmonics. This is the limit of one of the IEC standard, but actually if you do the detailed analysis, so I don't think so any of the parameter is meeting. THD is somewhere it is going up to 28%, and harmonics is less than 3%. In some of the it is going up to 24%, and harmonics order it should be less than 40, but it is more, is even up to 100th order or 120th order also it is present. So this gives the, in terms of R&D, okay, so this gives the clear picture of how effective my product design is. Okay, the requirement is THD is 5%, harmonics is less than 3%, or harmonics should be less than 40th order. But when you test it in the practical, okay, even after simulation with the any of the software, when we test it practically, this is a result. So now the R&D engineer responsibility has gone up to meet the requirement. Okay, so when we don't measure these kind of things, so how to control? So we should have a right equipment to measure these kind of parameters. Okay. Protection function for the grid connectivity. Like conditions when power conditions are connected to the grid, operating power conditions under the rated voltage and the frequency, changing the given condition, protector circuit must be disconnected quickly. So in a given condition, when the over voltage and voltage drops, like if it is from the nominal below 5% or above 5%, if voltage goes, so it should disconnect. Okay, and frequency change again plus or minus 5%, and reverse power flows. If it is that, also everything should happen within 500 milliseconds, less than 0.5 second, everything should happen. So that means we are talking about switching. Okay, How do we ensure that it is happening within that 0.5 seconds or whatever 500 milliseconds? So that is where the oscilloscopes or the scope recorder comes into picture. Okay, so for example, in a grid, so we'll connect the protection circuit and parallelly we'll hook up the DL850. So we'll connect it and leave it. So and we'll set a n trigger function. For example, in a day, maybe I can say 10 or 20 events can occur. So n trigger function, and I'll leave it. So one side I'm analyzing the voltage drop and voltage over voltage, whether it is plus or minus 5%. Sometimes the protection circuit, if it tripped, even the voltage range is less than 3%. So that means our set limit is not okay. Okay, and reverse power flowing, when the reverse current or reverse voltage flows, obviously it should trip. And islanding operation, so this is sometimes the power, it happens in the like avalanche, maybe that kind of islanding operation happens. Okay, so that time it should, within 1 second it should trip. So here the accuracy is not a criteria. Here the problem is different, like voltage, the over voltage and drop is 5%, plus or minus 5%. Frequency change is plus or minus 5%, and the critical parameter is timing. So the timing measurement is nothing but a waveform within that time. So oscilloscope and DL850 scope recorder is a timing measurement products. So how precisely? Okay, and I'll put one more parameter. So the protection circuit or protection, this thing, how much time it has taken to switch. One is it should happen within 5 seconds, but exactly how much time it has taken. So even though the critical parameter is 0.5 second, but whether it is switched within 10 nanosecond or 50 nanosecond or 100 nanoseconds, that timing measurement is also critical. Okay, so that can be measured using either through the oscilloscope or through the scope recorder. Okay, and power condition must be detect the islanding operation, and it should shut down. It should break the circuit. It should break the circuit from the grid, so that it will protect the equipment, so it will protect the grid. Okay, this is one of the applications. Okay, that is a protection circuit functional test in terms of the oscilloscope application. Okay, how we can use power analyzer for this protection functional test? Okay, islanding operation is detected by measuring the active power and reactive power. Okay, accurate reactive power must be measured by the harmonics mode. Okay, if you see here the display, this is a trend display which is we are talking about. Okay, and we have connected a WD3000 for observation of a protection procedure. Fast update rate of 50 milliseconds and trend display of voltage, current, power and reactive power. Q is nothing but a reactive power. Frequency. Okay, simultaneous measurement both normal and harmonics. Okay, there are equipments available. Either you can measure the normal voltage, current, power, frequency, or only harmonics. But simultaneously measurement of both, it is not possible. But whereas WD3000 can measure both simultaneously. Okay, total active power, fundamental active power of harmonics from the harmonics measurement, and fundamental reactive power from the harmonics measurement. So if you remember this table, if you see here, the one represents the fundamental harmonics. Okay, so the fundamental harmonics, so here that is what we are talking here. So the fundamental active power and the fundamental reactive power. So when you first, we have to get into the harmonics mode. In that harmonics mode, we have to measure the fundamental of our active power and the fundamental power of the reactive power. So based on this, if the reactive power is more, automatically the protection circuit should enable or shut down the circuit. This is the another option. So power conditioner system evaluation in the R&D. So here we can, like, if it is a single or three phase, depends on the application, we can use either WT 3000 or WT 1800. So up to 6 channel R. And here battery monitoring is also one of the key parameter. So if it is a more than 4 power measurement WT 3000 or 6 power measurement WT 1800. So if it is a like more than 3 or 4, you can use 1800. If it is less than 4, you can use 3000. So, and also battery monitoring. So the battery monitor is nothing but a DC. Okay. So level converter, inverter, filter, protector. Okay. And it is a AC load. So final AC load is calculated. So battery charging and discharging characteristics in a designing applications. So the WT series uses a digital sampling method that can evaluate polarity at each sample and perform integration separately by polarity. This effective when considering the optimization of the battery backup. So whether the battery is holding the sufficient charge or whether it is discharging in a fast track mode, or that to test this. So you can see the discharge current of a device in this graph. So how effectively it is discharging, that can be seen here. Charge and discharge integration. Okay. Okay, yeah. So this is the complete power analyzers family, from the low end to the high end, from the single phase to the best accuracy of 0.01% of basic accuracy. Okay, and we have a handle only for the commercial frequency for 50 hertz and 60 hertz, single phase, three phase, and then for the production line, and then for the medium like testing or QA, and then the R&D applications and QA testings. Okay, this is all about the power analyzers. Any questions? Any questions? Maybe they can also ask. Yes. Okay.
What is the cost of WT 1800?
WT
1800.
Okay, as I explained to you, this is a channel, number of channel. So you can configure from 1 channel to 6 channel, maximum 6 channel, minimum 1 channel.
Depending on the requirement of me, I can
Purchase it, exactly. So it's basically the cost maybe, Nikhil.
See, it varies from 10 lakhs to say 25 lakhs, depending upon the number of channels and number of options.
Options.
Couple of high-speed options, and depends upon the.
See, normally it's having a single harmonic measurement or dual harmonic measurement. Simultaneously, input harmonics and output harmonics. So both can be measured simultaneously. So that's also another option. So depends on the option, depends on the number of channels. So that can be configured.
Yes, any question from nodal centers?
Histogram or दिखा देते हैं.
Yeah, we will show that.
The oscilloscope will show.
We'll show.
Yes.
Any questions? Other?
Yes, we have any question from our nodal centers?
Okay. Nikhil, can you just explain this one functionality? Yeah, maybe in the front.
So you can come here for the.
That.
सर वहाँ ना मिरर इमेज आएगी
Oh, mirrors.
You can come there. Want to show histogram.
Histogram.
So that is on the vertical side. I will show you the. So this is the histogram. And you can configure the which channel you want to see. There are 4 channels. You can select the channel also. Then if you come to it, you can see the vertical histogram, which is coming here, and you can see the horizontal histogram also. And you can set up also here. And you can set the range, which range you want to see. This is normal function. Then channel functions are there. Then you want to display. Then there's a coupling. Then probe. You can connect a voltage probe and a current probe also. Then you need to set up. But attenuation is for a current probe 1:1 or 10:1 or 0.1:1 that you can change during this by this thing. You can change also. Then you can invert a signal also. Then there's a linear scale which was explained. Then you can label. You can name the channel also. You want to change it. Then there's a bandwidth filter which was explained, like we can go to 8 kilohertz. There you can eliminate the noise and see the signal. You can change it, like it is 100 megahertz, then you can still reduce it. You can do it till 8 kilohertz. This thing you can do for all the channels. Then there's a vertical section and there's a horizontal section. You can change the position of the signal and you can change the time division also. Then there's a trigger menu. Trigger menu, you can select which channel you want to trigger and what you want to rising edge or the falling edge. Then again the coupling, high frequency rejection off or on. Then noise rejection you can and window. Same. Then you can go to enhanced. In that there is a edge or edge qualified, state, pulse width, state width, and user defined and TV signals also. NTSC pulse signal you can say trace retest also. So if you select the pulse width, you can select which channel and then you can define. You can define the pulse width, say 4 seconds. So more than 4 seconds, less than 4 seconds, between 4 seconds to 5 seconds, out of 4 or 5 seconds, that you can define here. You're able to see or not here. You can connect it to projector also.
That's okay.
Out of range also, see you can select below 4 seconds and above 5 seconds. That also you can configure. So these are all configurable options which you can do. Same thing that you can do with other triggering options. Then we have a very unique as a B trigger. You can set one trigger as A trigger and then you can define the B trigger. If A happens, then B trigger happens, then it will trigger. So you can define that also.
Multiple
Multiple
triggers.
triggers.
Multiple
N
triggers.
number of triggers.
Yes. If this happens, A triggering, then you can define again A triggering, then you define the B triggering. Again, same options. You can do a double triggering also. So you can be very accurate in measurement. You what want to trigger and what measurement want to do. Then there's a zoom function. So you can zoom the signal horizontally. You can change the size of the zoom also. Plus you can change the location of the zoom also. And the good part with Yokogawa is that you can do a vertical zoom also. You can zoom it vertical also. You can do that also. Then there is a dual zoom. You can change the location of it and the size of it. So we are zooming on different parts of a signal.
Yes.
You can do that also. So you can, and zoom 2 you can do a zoom main signal also and zoom 1 also. And if you want to see what part of the signal, so the main signal is here, and zoom part you are seeing at a bigger level, and you can do a analysis on it. And then on top of it, vertical zoom is there. Then there is a feature known as search. You can search certain. You can put a criteria, say pulse width. Then it will pinpoint the marker. Like see if I do. So if you see, it has come, some pointers have come in. You can define those and you can search, and automatically you can define the search and it will automatically what are the points and where the value is. You can do automatic search also. Then there is a cursor measurement which is there. So horizontal cursors are there, vertical cursors are there. Then you can do a both the cursors also, horizontal and vertical cursor you can do it. Then there is a marker also. You change the position of this marker, and you can get the value at particular point also. And you can define for all the channels. Then coming to measurement, which was around 20 measurements simultaneously, you can see which channels and what are parameters you want to see. If you want to see maximum value, then you want to see RMS value, or if there's a sinusoidal or repetitive signal, you want to see the pulse count also. Then if you want to see a frequency or rising time, so all the values will come here. You can see this value, automatic measurements are there. Then coming to analysis part, one was histogram, which I've already explained. Then there is power analysis also. You can do the switching loss also. You can measure switching loss. You can set up the current and the voltage, and it will which channel it is voltage and which channel is current. Then you need to configure the attenuation of the probe also. Then you can see the mathematic application things also. Then there is safe operating area. For designing your IGBT MOSFET, you need to have a safe operating area. You can have this also. You need to configure again the probes, input channel and probe, then it will be configured. Then coming third one is harmonics. You can see the harmonics also in the instrument, and there is a list also available. You can see it too.
Numerical list
Yes.
of harmonics.
Till 40th order you can see 40, and you can directly plug a pen drive, and you can directly save, and in the laptop or in a desktop you can directly, it will open as an Excel sheet. This is a harmonic. Then there is a I square T energy in terms of joule also you can measure it. So these are all advanced application and measurement which is available with for the power electronics application and measurement. And you can do it for a two different measurements you can do simultaneously. Then there is a power measurement also. So we'll start where we continue where we stopped for the demonstration of a oscilloscope for a power electronics applications. We're doing this analysis function, histogram function, and there is a power analysis function where you can do switching loss, safe operating area, harmonics, and I square T. Power measurement, it on, then you can set up the measurement. Item setup, you can say voltage peak, then absolute power, reactive power, apparent power, frequency, and same in the current peak, positive peak, negative peak, root mean square, and the power factor also. Absolute power also you can measure. You can select the parameters. Just escape. So these values will come here. Absolute power and other parameters are coming here. And you can select the calculation setup also. You can define your measurement values also. Then coming to mathematical functions, you can multiply two signals, then subtract two signals, and you can put an integration function also. And you can select channel 1 minus channel 2 minus channel 1. And you can label those also according to your requirement. You can rename also. Then the display, you can this is a single display, then you can have a dual display, then you can make it up to 4 displays. So it is 6 displays also. You can split the display also. Then connectivity is there, then it's the dot matrix or how you want to see the signal also. And you can change the color also. If you want to change the color of any signal, you can change the color also. You can change the color also. Then intensity you can change, color gradient, and you can change you can put it off also. Then acquisition, you can change the record length of the instrument, which is the memory. It can go to 1.5 kilopoint to 2.5 kilopoint memory. So 2.5 million point memory. Then you can put in the instrument into normal mode and high resolution mode for faster application and measurements. Here it comes for the saving functions. You can save the signal into the internal memory also and directly into the pen drive also. You can save and you can rename also functions. You can save in PNG, JPG, BMP, all the formats you can save. You can save in again black and white also. You want to which color you want, you can invert the color also, and then you can recall and this function. These are the saved functions. You can recall also. These are the various features, and back all the computer connectivity is there. You can connect the monitor also, USB port is there, pen drive and computer. You can connect the printer also over here. That is regarding oscilloscopes. Then coming to power analyzer. So this is a low current power analyzer. So you get all the displays over here in LED. You can configure the function whatever you want: voltage, current, watt, apparent power, reactive power, then time, frequency. You can say the power factor also. You can see the efficiency also. You can change the VAR, time, and it is a 3-phase. So you can change the phase also, channel or the phase also. 1, 2, 3. Then you have a sigma also. So you can see first channel voltage, and you can see a voltage of second channel.
It comes to 0.
Of third. You can compare all the voltages or the current or power of all the 3 phases simultaneously. You can change it.
So right now input is given.
Abhi sir, nothing is connected. You can connect anything. For that matter, I can show you connections also. It is a simple voltmeter connection. Voltmeter connected to parallel, and current is connected in series. So there is for the first phase, and all the Ethernet port is there, RF232 port is there, USB port is there, and GPIO port is there. So there's a software along with that, you can connect the instrument, you can control through your computer also, and all the data can be automatically data logged into the computer. So you can change the voltage readings levels here. You can change the range also, or you can put in the auto range also. Similarly, for the current application, current measurement, you can change the current range. It can go to 20 ampere in the auto range also. Same thing, you can start the integration for the power measurement, energy measurement with respect to time. You can use that. Then you can have a, you need to set up for the scaling factor or the CT ratio. You need to here. CT ratio is there for all channel or individual channels. Then for harmonics measurement, which sync source you want, current and voltage. Then which first channel, second channel, or third channel current voltage you want. Then this line filter frequency. You can all configure here itself. Updated after how many seconds you want the data. If 100 millisecond to 5 seconds, you can set it here. Let's say 5 seconds also. Then interface connectivity, GPIB or USB Ethernet, you can configure here. USB it automatically detects into the computer. Then you can, if the harmonics, it can go show up to 50th order harmonics. The order you can see, then by up and down arrow you can see the values also. Currently we are not connected anything. Till 50th order you can see the harmonics.
Real time, if it is possible to calculate all these values, see all the observe all these values like voltage, 230 volts is there. Well, measure from somewhere like from this plug. Supply में connect करके भी देख सकते हैं. And see all this power, reactive power, harmonics and all that. It will be better observation. If there is an LED, load is there. They have to pops directly pops into.
Just switch off this.
You want multimeter kind of placement and can use DLV.
Or try to put it there, push it, small one or big one. No. Keep it here. Take an extension. No, that will not go. That will not go. Chota wala. Will it goes? No. See? But give the black one also. Okay, I connected.
Voltage or current, whatever.
I'm just connecting to the voltage.
Sound like it, man.
Just check.
Yeah.
Okay, sensing.
Yeah,
Okay, I updated. I slowed down.
Just check.
242.
Exactly.
Okay. Maybe what you can do this. Connect the same parallel.
Connect
Take
the
the
person.
reading, so it can-
Take 2 more cables. Tap it from there. Tap it from there.
Camera में तो हिंदी से है। So the reading purposes of-
Tap it. Tap it there itself. इसके पीछे. हाँ, पीछे लगा. पीछे लगा. हाँ. ये वाला को
Yeah, two are coming. Two knobs have been connected.
टेक वन मोर. सब चैनल को भी ऐसे डालो. अच्छा, दोनों आ जाएगा. हाँ.
Three probes, two probes are coming.
Very simple connection. Voltmeter connection, ammeter connection. 2 terminal for voltage, 2 terminal for current.
Yes.
So
This is the real time we have
exactly. See, normally this is no what I can say. It's like a real time.
real time on
Yeah.
set monitoring.
Instantaneous voltage multiplied by the instantaneous current,
Exactly.
and it will give you the instantaneous power. Okay. So you might be then what is the energy? So energy is nothing but a watt hour. Okay.
Time.
So there is an integration mode here. If you switch on that integration, so it will calculate the total cumulative power with respect to time. So that will become the watt hour.
For energy content WH,
Yeah,
you will get kilowatt hour.
Watt hour, and once it's go above 800 watt, it will start 0.1 kilowatt, 0.2 kilowatt. So it may kilowatt mein ho jayega. Show the frequency, niche error.
It is 49.8.
Change update rate, slow karo. It will.
It's still slow. It makes it perfect. 5 seconds.
If you want sometimes when you connect this to the PC, okay, you want to acquire the data in faster, like 100 milliseconds. So update rate is equal to the data transfer rate, 100 milliseconds. If you want in a 1 second, so every 1 second's data will be pulled down to the PC. So depends on the application, depends on the requirement. So you can set the update rate.
See, we have not connected current. You can
Select power factor will not come because we have not connected the current. We have not connected the current.
Yes. Harmonics.
Voltage harmonics. First one, second, third.
Yeah.
Yes.
Light glows over here. You can see all the 50 harmonics over here.
If you connect this PC, you have a laptop with this one, software of this. Can you, but USB cable?
Yes, I have.
Please. Okay,
You
we
can
have
extract the data and
a software, free software.
Yes.
Okay, once you connect it to the equipment, so the same reading will come to the PC. At the same time, in the PC, you can see the waveform also.
No, that one is exactly.
You remove the DLM.
Okay.
Remove the DLM and put it there so that focusing will be better.
Memory.
Focusing will be better. Push back. Careful.
इधर घुमा दीजिए.
It's connected. You can do the settings from the PC itself.
Okay.
You can control the equipment and you can pull the data. You can do the analysis.
Yes.
Go to waveform mode. First you can show the numerical.
There, if you see, you can select what all parameters you want to see. for voltage, current, power, mathematical function,
Around
harmonics.
48 different kind of parameters are there. So you can select what kind of parameters you would like to see. Same thing it will pull.
And which phase, first, second, third,
Second, third phase.
Yeah.
you can do. And you just need to put the start. The voltage just start coming. Voltage.
Okay, real-time voltage.
And also it will say what is the minimum, what is the maximum in that time period.
It can be recorded.
Sorry?
Yeah. The data gets recorded into Excel file automatically.
It gets recorded.
Recording. Yes. You can save the data.
Can you say the mathematical function? Is it possible?
Mathematical like
No, you have said now mathematical.
That is efficiency.
efficiency. Yeah.
Input output efficiency.
No, we have only given that.
So you can see the waveform also.
Fine.
And you can see all the harmonics till 50th order also here.
Yes.
Bar graph. Waveform. Right click. Bar graph. No. Yeah. Bar graph. Yeah.
You can see the value is changing also.
Voltage harmonics.
Oh, that's good.
So current will come here.
Hmm.
You see all harmonics which are. Very easy USB connection. Automatic plugin. Here you can see the trend also. How much value is it is increasing or decreasing over the period.
Yeah, good.
And the beauty of this is if you configure with the Ethernet port, okay, anywhere sitting in the campus, maybe you can sit at your room and you can control the equipment. If the equipment is there in your lab, or it is there, some testing is going on, or you want to change the settings, or you want to do some this thing, control can be done
Yes.
through Ethernet and
That's better.
Remote control can be done. And similarly, you can create 4 instruments in a single software.
so different data, like this will be identified as a WT1, WT2, WT3, WT4, like that with a different identification number. It will give the data and it will store the data in the same Excel file. So data compiling will be easy, and comparison, and you can plot the graph also. Similarly, all our equipments, like including 1800, 3000, we have some minimum software which can pull the data. At the same time, we have a licensed software which can do much more detailed analysis, like as per the IEC Harmonics, which you want to do the analysis, or flicker analysis you want to do. So dedicated softwares, licensed version of softwares are available. So that can be interfaced.
And they will generate report as per IC standards also.
Flicking, mainly flicking is very important.
Flicker, yeah. If there are some
motors and lightning aspects.
exactly, yes.
That I call it as electrical pollution.
Yeah. Remove that, it will be congested.
That's the problem. Experimentally, we can do.
Let me show you without connection. People might not understand.
Yeah. Be careful.
See, this is again we're talking about 3-channel over here for 3-phase measurement. So this equipment WT1800 has a 6-channel. It can do 3-phase input output efficiency also, and you can do the solar testing also for the renewable applications also. One side you need 4 channels, or maybe inverter circuit, maybe chopper circuit. You need 6 channels, 4 channels, or that. You need this confusion, and all the communication ports are there. And you can also do the motor testing also. You can connect the torque sensor and the speed sensor into the power analyzer also. So these are the BNC inputs for that. and same connections, voltmeter and ammeter connections are there. You can directly feed up to 55 ampere directly over into current. Yes. Above that, you need the clamps also.
Directly up to 55 amps. Through clamp, you can go up to whatever the kilo amps or whatever you want.
Yeah, you have already mentioned in the
Exactly.
Yes,
exactly.
Yes.
Connect, do the connection.
Open the. I will do the connection.
ग्रुप बना लेना मेरा व्हाट्सएप
Copy it in the pen drive because my system is connected. Okay, now we have tapped the only voltage at this point of time. We have tapped the voltage to the all the 6 channels. We have connected the 6 channel voltages. Come, we'll just come
Corrected voltages.
First, go with the numerical setup. Full, bigger one. Or again. Numerical. Press numerical twice. Once again. Once again. Once again. Yes. Voltage. Change. On all. OL because of its overload. When we are setting it at 15 volts, now 300 volts it's coming to select all. Shift all. Yes. Now you change the setting. Okay. Now you go to grid. Press memory. Once again. All are coming. Once again. See, all are coming now.
Yes.
You can see in this one more advantage is you can configure the
Pages also.
each and every readings as per your requirement. Like, see, only 4, it will become a bigger one. Okay, or 8 readings per page.
Yeah.
Okay, so for example 4. Okay, Nikhil, press page down. Second channel, third channel,
यहाँ पे there are around 12 pages. You can change the page also.
Pages also.
Page 4, page 5, page 6. And you can
Similarly, you can see here URMS 1, URMS 2. 1 stands for this first channel, 2 stands for the second channel, like that. VRMS, IRMS, power factor. So you can
efficiency. And you can configure this page also. If you want to change, say if you want to change from I to W, you can go to W. And you want to change the element instead of first, you want second, you can change the element also. So it is totally configurable. You want to change it to frequency part to frequency. Then if you want to change the element 2 to element 3, you can change the element. So anything you want to display item change, you can do it anywhere.
So it is a, as I said earlier, it is a normally R&D testing equipments. It should be user configurable. There should not be any restrictions, because if you have a restrictions in the measurement portion, we will not be able to analyze as per our requirement. So this is completely each and every parameter, including filter setting. With respect filter setting of 0.1 Hz, you can change it, so that you can analyze your device, how it behaves with a different filters or different frequencies. So you can completely do the customization as per your requirement. Not only display, including the settings also.
And if you want filters, individually channel you want to configure, you can do it. Similarly, other filters, which frequency level and what all channels you want to do it. Display.
Change it to all channels. Numeric. Once again. Yeah. See now all the 6 channel, you can see it in one.
All the values.
All the at least now we can show the voltage value
Of all the channels.
voltage, current, power, apparent power, active power, lambda, cos phi, frequency, voltage, current, frequency. You can do every time, power, positive, negative.
Go to waveform.
You can see the waveform.
Again, once again.
Plus, but
4 channel, 6 channel. All the 6 channel waveform you can see.
plus you can, if you want to see, say,
Numeric plus
numeric
waveform.
plus waveform. So, numeric also coming here, and you will see the waveform also. Or numeric plus you want to see bar graphs of the harmonics. It is all configured. Vector diagram, or you want only vector diagram, bar graph, trend. What is the trend? You can see 2 things also at one time, or one thing also. That is, everything is configurable here. Within the update rate also, you can increase the update rate, decrease also. Similarly, but we are doing it.
It's having a inbuilt thermal printer, so you can take the printout also. Screenshot, you can take the printout. So you have a USB ports where you can connect the mouse, keyboard, pen drive. You can store the data directly to the pen drive.
And
And
similar software is available for controlling the instrument also. Ethernet port is there. You can do. Even for renewable energy application, currently that MNRE has bought this. Yes. For their-
MNRE, that is nice, National Institute of Solar Energy. Yeah. So there we have with the 6 channel fully loaded, 6 channel with a high capacity CT 200.
or their International Solar Alliance application requirement for all the solar cell testing. They're doing it.
So with respect after the with reference to,
mainly concerned with solar only.
yeah, with reference to that, ERTL Kolkata has purchased for same solar inverter testing, and ERDA Vadodara has tested for the same applications.
Even Terry
Yeah,
is,
Tata Energy Resources.
they are also planning to buy this one for same
It
application.
is the need of the hour.
Yeah, NPL has purchased a bit lower version due to budget constraint.
Physics lab.
National Physical Laboratory.
They are
So,
related only.
that is a
IIT Roorkee has bought this for same
solar application.
Yes, EHEC department.
They have the hydro department.
Yes. Same hydro.
These
alternate
all are
hydro.
interrelated.
Yeah.
All you are taking. Even CVT there in Pune.
Exact. CVT is there in Chennai also.
Tamil Nadu.
Yes.
Yeah, CVT is there. These all are interrelated.
Interrelated.
Even NIR is there in Kapurthala. You can
Yeah.
go and visit over there. So National Institute of Renewable Energy. So that's Varanasi.
Okay.
Even they may be needed in this all departments are working with the renewable energy, and this is one of the impact factors. So I was very conscious to look into it.
And even IIT Delhi,
IIT BHU.
BHU.
When I was in
Yes, they are also bought this for the same renewable energy application.
IIT Delhi also has a wing for the Center for Energy Studies.
But we have sold it in machine lab.
We have more sold in machine lab, same.
I think 2 numbers there.
Yes.
2 numbers. Okay, similar to motor application. Motor application with using WT 1800. We have one small video. Maybe we'll play that. Okay, I will play that and then we'll next DL 850. Getting copied.
Yeah.
Remove this.
Yeah, you remove that.
We keep dealing.
On.
इसको कोड हमको पता लग गया कितने आएगा हमको चिकन मिल जाना सर बैठा नहीं
So it is a scope recorder. It is with scope with recording capabilities, and see, you can configure the number of channels over here. In voltage, current, temperature, pressure, strain, you can put. It is a total modular based solution for temperature or maybe RPM. You can do automotive signal also. And you can connect the motor connectivity into this also. Torque and speed sensor into this also. All the GPIB port, Ethernet port, and USB port are there. Same channel, you need to configure labeling and probe connection, filter delays there. And then zoom if you want to say, then offset if you want to set up. Similarly, for all the channels, you can do that. Then there's time per division. You can change. You can change the position also, because when you connect multiple channels. You can change the position of it also. Then same, you have zoom features over here also. Dual zoom is there. Then you have triggering options also. Same triggering, and now you can set the trigger also. Same pulse width, and you can change the this also. Then analysis function, power analysis also. You can wiring diagram you want to change. 1P, 2W or 3-phase, 3-wire, 3-phase, 4-wire, 3VA, 3A method. You can configure and you can set them. Which channel is voltage, which channel is current. You can do harmonic analysis. You want to set line or power. Then which channel you want to set Then you can see the harmonics also. Then you want measurement setup. Again, same peak to peak, and what you want, you can select lifetime, frequency, peak to peak, lifetime and frequency are coming. Values come here also, and you can see values here. This all you analysis can be done here. Then cursor measurements are there, horizontal cursors are there. Then you can have a vertical cursors are there. Then marker, you can keep the marker, you can change the position of the marker. In that particular point, what is the value you can see. Plus you can store, you want to store the data, you can store also data, and it can do the recording part also in the internal memory. You can take the snapshot also, you can save it. It is saving the data also. Save file, which format you want to save, and you just execute save. So it saves, and you can do the file number also. And if you want to save into image screen, then JPG, BMP, and PNG format you can save. And similarly, you can recall the data. According to time, you can select which one is recall the data also. Main thing is for the recording capabilities for long period, what is happening, you can record the data. So copy the data. You can.
Yeah, before that, I'll just show that some of the this one applications with the motor, related to motor applications. Okay. Basically, for the motor and inverter applications, like for inverter setting, you need to care for the range setting, and range information makes you understand easily the range you are using. This function let you decrease the setting mistakes. So if you see here, so the inverter has been connected to the motor, and motor has again, it has been connected to the load. Load either could be, say, a regenerative motor, or it can be a so the output, if you see the below that blue color, those are all the CTs. So which for the high current CTs, which is connected to the power analyzer. If you see in the left side output signal where, so it is a PWM signals, so without filtering. If you put the filter, so you will get a pure sine wave. Okay, and this is the speed and torque sensor output, which is again fed to the power analyzer, so that it can analyze the or calculate the mechanical power and input electrical power. Here, if you see there is an option of calculating the 4 kind of accuracies. Efficiency. One is the inverter efficiency. So the inverter efficiency can be calculated by 3-phase output divided by single phase input. Okay, and the motor efficiency, motor efficiency can be calculated by mechanical output divided by three-phase electrical input, and the total efficiency. So the total efficiency is the mechanical output divided by the single phase input. That will become the total efficiency, which includes inverter and the motor. So at a different load, maybe load may be at 50% or 100% or 75%, whatever it is. So if you see here, the readings are all like voltage, current, power factor, phase angle, frequencies, and all those things, and the efficiency. And here the again, which is with respect to element 1, 2, 3, 4. So these are all the overview of the complete range settings which we have done here. So this is one of the application for the motor and inverter. So the advantage is high speed range changing. So sometimes like within a fraction of second, the like from the when the motor started, it will go to the highest peak because of the starting current, and then it will stabilize. So that happens within a 3 to 4 seconds. So within power analyzer should be able to respond to that fast changing signals. So the high speed capturing signal, it's a 5 millisecond. So when we have a 5 milliseconds of response time, so it is not a difficult for the power analyzer to change it to adapt to that changing signal and capture that. So one thing is we can plot the inrush current, which is a motor startup current, and also after stabilization, what is the power. So that is the high speed range changing, and electrical angle measurement like A, B, and Z phase in terms of speed. So if you see the pulses here, so these pulses are can be used to calculate the phase angle of the AB's Z input of the speed. Okay, so if you see overall industrial applications like wind or hydro or thermal or motor applications or even transmission, solar applications, PV applications, and the distribution, transformer, and the office, and the generators and inverters, railways, and power R&D or BIS star rating or whatever it is, and the consumers and home appliances or houses. So from the, if you see the all areas which we are talking about, the power electronics or these things, so for all the things we have a solution in terms of the either as it is starting from a multimeter or single phase power analyzer to the high end power analyzer or the scope recorder which can record the data. And these are all the applications, some of the applications, industrial applications, automotive industrial applications. Some of our key customers like BHL, JSW, and Honeywell, SAIL, Emerson, Bajaj, Bosch, IITs, NITs, Samsung, Mahindra, Toshiba, ONGC, all kind of customers. This is a one, and I have one more interesting application which recently this is like the maximum evaluation of maximum as per the Euro and CEC efficiencies for the power conditioners. So as per the IEC 61683 publications, so in the European market and US market, the efficiency, the maximum efficiency, which is generally value where the efficiency is maximized under the certain specific conditions. So if you see the rated output power with respect to the efficiency, so as of now we have almost touched 97 plus as per the CEC. So photovoltaic supply, power conditioner, and simulated AC power supply and load. So if you connect the WT 1800, the maximum efficiency which can key issues in this certain areas are some products with maximum efficiency at their rated output at 100% load. What will be the efficiency? And efficiency data of power conditioner test evaluation based on the standards specified by the California Energy Commission. Okay, Euro efficiency is Euro ETA partial load efficiency. The Euro efficiency is used in European regions This is a conversion efficiency using evaluation criteria consistent with European climate changing policies. So with respect to different temperatures or different humidities, what could be the efficiencies? So this is one of the applications. So in the rated load efficiency measurement of power conditioner, so if you see here again PV module and power conditioner with a load. So rated power means what is the maximum rated power. So at that, what is the power losses and what is the ripple ratio? Okay, and calculation of the DC ripple and AC ripple in as per the defined. So one more this thing added feature of this 1800 or 3000 is 20 user defined functions. User defined function in the sense you can put the formula whatever you want, like channel 1 to 6, whatever the like arithmetic formulas you can put or mathematical formula, it will calculate and it will give that results, so that 20 formula can be derived from the any of the parameter of this 6 channel. So that is the one advantage of this. And in terms of motor applications, I have one video, maybe I would like to show that. Good morning. Today the whole world is debating on how to reduce the power consumption, and the industry, the water is the main consumers, the largest consumers of the power in the sound.
Yes.
It is estimated around 45% of the world power consumption. VFD plays a very important role in reducing and controlling the power which is consumed by the motor. Here we have a unique product in its class from Yokogawa. It's WT100, which is having 6 input elements which can directly measure 6 inputs at a time, and it's having a lot of additional features like high speed data capturing and pulse width modulated waveform measuring, and input and output of an inverter simultaneously it can measure. And the unique feature of it is the dual harmonic measurement of both voltage and current of any input element. Here we have connected motor and the load through a VFD, which can precisely measure the power consumption of a motor and the efficiency of a motor and efficiency of a VFD and the total combined efficiency of a VFD and motor. Yeah, WT1800 is having a 6 individual power channels which can be used as an independent power meter as well, that combined with a 2 or 3 element can be combined. These are the voltage terminals and these are the current terminals, and it can also having a external sensing input which can measure high currents, and it's having a to calculate the mechanical power, it's having an input of speed and torque, speed of A, B and Z angles and torque input, and also it's having a latest communication ports like Ethernet, USB, GPIB, and it can be interfaced to computer to make it automated test system. And also right now this connection as connected to the motor as well as VFD to make a calculate the efficiency of a motor as well as VFD and a total system efficiency. Here you can see the complete display of the independent power element, voltage, current, power, apparent power, reactive power, power factor, frequency. Even though it is pulse width modulated frequency, here you can see the motor, load, VFD, and power supply to the load, which is VFD is running at a frequency of 30 Hz based on the load. Okay. Mechanical parameters can set using this screen, like speed parameters like scale, unit, and whether it's an analog input or pulse input, and the linear scale and line filter, sync source. Similarly, the torque parameter can be set. What is the torque scaling unit, where it's again analog input or pulse input, and the range, linear scale, and the upper range and lower range, and again the poles, number of poles, and sync speed, and the source, sync source. All those with the rated frequency for to calculate the mechanical power. Good morning. Today the whole world is debating on how. Sorry, that is a video of this. Any questions? Maybe in the like so far whatever we have done.